Question number 18. Two bags P and Q contain identical marbles except for the colors. Bag P contains 3 green and 4 red marbles. Bag Q contains 2 green and 3 red marbles. A. Find the probability of picking a red marble from bag P. So let's begin with that. We have 2 bags here, and bag P contains 3 green marbles and 4 red marbles. Now we're supposed to find the probability of picking a red marble from bag P. Now to find the probability of picking a red marble from this bag, just look at the number of red marbles, there are 4. Then you divide by the total number of the marbles in that bag. That is green plus the red, which is 3 plus 4. So the probability of picking a red marble will therefore be 4/7. Part B. 2 marbles were picked at random from bag P, one at a time, without replacement. 1. Draw a probability tree diagram to show all the possible outcomes. 2 marbles were picked from the bag P without replacement. Those are the keyword here is without replacement. Then there are 2 marbles. They are picked from bag P. We already know that bag P contains 3 green and 4 red marbles. So to draw the tree diagram showing the possible outcomes, remember 2 marbles are picked. So the first pick will be represented by that branch. Green, red. What is the probability of picking a green marble? Greens, how many greens are there? There are 3. And the total marbles, 7. Red, there are 4 red marbles. So the probability of picking a red marble will be 4 over the total marbles, 4/7. That is the first pick. Now let's go to the second pick. For the second pick, you have to draw another branch like this. These all represent the second pick. So you have green, red, green, red. There's a keyword here, without replacement. So what do we mean by without replacement? This simply means that the moment you pick a marble from the bag, the total will change. Like in this case, there are 7 marbles. If you pick 1 marble without replacement, you remain with 6. If there are 3 green marbles, you pick 1 green marble, you remain with 2 green marbles. That is the meaning of replacement. Once you pick the marble, it is gone, the total changes. Like in this case, the first for this green, the moment you go and pick the second green, the greens were 3, so it reduces by 1 in the second pick, so you'll have 2, and then the total will not be 7 because you've picked 1 green from that bag. The total will be 6. Automatically, the other branch here for the red, you'll get 4 divided by 6. Why? Because the sum of the probability in each branch should be equal to 1. Like in this case, 3/7 plus 4/7 should get 7/7, which is 1. So the moment you get 2/6, automatically you know what is remaining to make that 1, 4/6. So that when you add, you get 6/6. All the same, in this branch, they have green. When you pick a red, the reds are 4. So the probability that branch will be 4 divided by the total, because you are picking from a bag that contains 7. So the moment you pick 1, you not have 7, you have 6. For the other branch here, where you have red, you're picking green. So the greens will remain to be 3, because in that branch, this is where you have red. So the greens are not affected. So you have 3 divided by 6. Since this is the second pick, so from 7 you pick 1, you remain with 6. Then the other one is going to be 3 divided by 6 as well. Why? Because this one is red. The moment you pick another red, the reds are 4, so you pick for the second time another red, so the reds are going to reduce from 4 to 3, then the total changes from 7 to 6. So that is what we mean by probability without replacement. That is a probability tree diagram, and it is always good to complete it like this. For this branch, green green, then here you have green red, then here you have red green, and then the last one you have red red. So that is how you're supposed to do that. Part 2, find the probability that 2 marbles picked were of the same color. Find the probability that the 2 marbles picked were of the same color. So from the probability tree diagram, just look at instances for all these outcomes that are here. Where do you have 2 marbles that are of the same color? This is the first one, green green and red red. So this one will be the probability of picking green green, or the probability of picking red red. Don't forget that the language of probability, or when you talk of or in probability, we add, then and, okay, like this one, the probability of green and green, green and green, we do multiply. But here, probability of green green, or we are going to add. So this is how we do it. Probability of picking green and green, you just come and take 3 over 7 multiply by 2 over 6. That is what we mean by and. We multiply. Then or we add probability of picking red and red, red and red. So red, look at this branch, 4 over 7 multiply by 3 over 6. So this will give us 6 over 42 plus this will be 12 divided by 42, and this will give 18 divided by 42. You can simplify this one further and you'll get this one is 3 divided by 7. Part 3, find the probability that at least one red marble was picked. Find the probability that at least one red marble was picked. What do you mean by at least one red marble? At least one, remember they are just 2 marbles, so at least one means one or more. That is the meaning of at least. At least one. So for these outcomes, you're going to look at these outcomes and check where do we have one red marble or more. And you notice that we have this one, we have this one green red, this one red there. At least one means one marble or the 2 marbles are red. One marble or the 2 marbles are red. So here you have green and red, we have one red green, we have one red, and then here we have the 2 red marbles. So these, the ones that I've ticked, are the ones that are supposed to calculate. So you can do it using the 2 methods, but I go for the shortest. The first way, you can get the probability of green red, or the probability of red and green, or the probability of red and red. Then you multiply all these and add. So like here you get green green, not green green, green red, you get 3 over 7 times 4 over 6, or you add red, green, red and green, you have 4/7 times 3/6 plus red, red, we have 4/7 times 3/6. That is one way. But this is the longest one. This is the shortest way. The shortest way is whereby you should know that the sum of the probability in this probability tree diagram, when you add all these probabilities here, that is green, 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 red, red, green, red and red, it should add up to 1. And when we look at all these outcomes where we have at least one red marble, you only find it is only one instance where we are not having red, and this is why we have green and green. So since you know the total outcome, the sum of the probability in this probability tree diagram for all these outcomes when you add is 1, if you subtract the probability of picking green and green, you remain with all the other 3. The sum of the probability is equals to 1, so you just take 1, then subtract the probability of picking green and green, you remain with all the other 3 outcomes: green, red, red, green, red and red. So this is the easiest one. Just take 1, subtract probability of picking green and green. Green and green is 3/7 times 2/6, and this one, when you work it, when you work out this, give 1, subtract this will give 2, 1/2, 3, 1, this one 1/7, and this will give 6 divided by 7. 1 subtract 1/7 will be 6/7. The same case to this, when you work out these, you should get the same solution. Part C of the question: the marbles picked from bag P in B were both put into bag Q. Marble was then picked at random from bag Q. Calculate the probability that the marble picked was 1. Green in color, 2. Red in color. Then I have begun by drawing a tree diagram, and in this tree diagram you can see there are 3 branches. The first 2 branches represent the marbles from bag P. Remember that these are the ones that we drew earlier on in part B1, the 2 marbles. So those are the 2 marbles that are being put into bag. So the whole of these, let me start by, so these are from bag P. Then the last one represents now the bag Q, and the bag Q will have now the total of the number of marbles, 2 marbles from P, and then the ones that are in Q. So let me begin by looking at these bags, bag P and Q. Bag P contains 3 green marbles and 4 red marbles. Then for Q, it contains 2 green marbles and 3 red. So I'm doing this in order to get the total. So what will be the total number of marbles in bag Q? It will be 2 marbles from P plus the marbles in Q. The marbles in Q in total, 2 greens and 3 reds, there are 5 marbles. Then the 2 marbles that will be brought from bag P, 2 marbles only. So in bag Q, we shall have a total of 7 marbles. Now remember, in this question, there's no condition like in the first, in the previous part, where we are supposed to work it without replacement. This one, the total will not change because the statement is very clear. A marble was then picked at random from bag Q. There's no condition like without replacement, so the total will not change in this case. So that is the tree diagram that will help you to work out these. Now we need to fill the probabilities in the last branch, and this is how we are going to do it. The first branch, you picked green and green. Those are two marbles, green, green. Two greens are being put into bag Q. In bag Q, how many greens are there? There are two greens. There are two greens. And then two greens from bag P. So those are a total of 4 greens. So the probability of picking a green will now be 4 divided by the total. The total will not change, 7 marbles. Then for this one, for red, you have 2 greens. So you bring them into bag Q. So the reds will still remain to be 3. There are 3 in bag Q. So it will be 3 divided by 7. Let's go to the other branch, green and red. The two marbles from bag P are green and red. So that is 1 green. So if it is 1 green and 1 red, if you put that into bag Q, where we have 2 greens, then you bring 1 green. Those are 3 green marbles, so it will be 3/7. Then the reds in Q are 3. Then you add this 1 red. So the reds in Q are 3. You add 1 red, that will be 4. It will be 4 divided by 7. The next branch, red, green, red, green. 2 marbles from P. One is red, one is green. You put that into Q. Into Q where we have 2 greens. So you add 1 green to be 3/7 again. Then the reds are 3. So add this 1 red here. Will be 4/7. The last branch, you pick the 2 to be red and red. So red and red, we don't have any green, so the greens in Q will remain to be 2, so 2/7. But now when you pick red and red from P and put it into Q, here we have 3 reds. So those are 3 reds in Q plus the 2 reds in P. That will be 5/7. So that is how you're supposed to fill it. Then from there you can complete these. So the first branch here, you have green, 3 greens, green, green, green. Then this one will be green, green, red, and then we have green, red, green, green, red, and green, and the other one green, red, red. This one will be red, green, green. Then this one will be red, green, red, green, and red. Then red, red, and green. Then the last one will be 3 reds. Now the tree diagram is complete with the marbles from P and the marbles in Q. The question is, calculate the probability that the marble picked was green in color. You need to be very careful here. The question is very clear. A marble was then picked at random from which bag? From Q. And what represents bag Q? It is the last branch. So to get the marble that is green in color, we shall look at the third marble. Like in the first case, we have green, green, green. The first 2 greens are from bag P. But the question is a marble that was picked from bag Q. So we are going to consider the last green because the first 2 greens are from bag P. Then the last one is from Q. So the first one, you're going to consider that. So that is the first one. Then green, green, red. This one is not included because you can see the last marble in bag Q is red. The other one is this. You can see green, red, green. Green and red, that is from P. The one that is representing the marble in Q is the last one, green. So that one is also, you have green. The other one, we have this one, red, green, green. You can see red and green, that is from P, then green. So we are looking at the last marble, where we have the last marble as green. So that is the one. And then we have the other one is red, red, green. This one, also the last marble there in Q is green. I don't think we have any other. We don't have any other. So those are the only ones. So we have this green, and then this green. So we are not just checking the outcomes where we have the green. No, there is a condition. It is where we are picking it from bag Q. And what is representing bag Q? It is the last marble. So we are checking these outcomes where the last marble is green. So those are the ones that I've picked. So now you need to calculate. So this will be the probability of green, 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 or the probability of green, red, green, or the probability of red, green, green, or the probability of red, red, green. So let us work out these and be very careful. The first one is 3/7. 3/7 times 2/6 times 4/7. Then plus the other one is 3/7. That is green, red, green. 4/6 times 3/7. Then plus red, green, green. We have 4/7 times 3/6 times 3/7. Then the last one is red, red, green. So we have 4/7 times 3/6, then times 2/7. So those are the outcomes and the probability that the marble picked was green in color. So now we need to simplify these. 3/7 times 2/6 times 4/7. When you work that and simplify, that will give 4 divided by 49. Then plus, so that one is done. So this one is 3/7 times 4/6 times 3/7. That one, when you simplify, it will give 6/49. Then now you're in this 4/7 times 3/6 times 3/7. That will give 6/49. And then this one, the last one, 4/7 times 3/6 times 2/7. That will give 4/49. Working these, you add 4 plus 6 plus 6 plus 4, you get 20 divided by 49. And that is the probability that the marble picked was green in color. The last one, the probability that the marble picked was red in color. Red in color. Now this one is very easy. All the probability that we've got here, whatever we have ticked in the first part, that is part 1, is the probability that the marble picked was green in color, where the last marble is green. So all the others that are remaining, are the ones that we require, are the ones that represent probability that the marble picked was green in color. Like this one, you can see the last marble is red. This one, the last marble is red. This one, the last marble is red. And this one, the last marble is red. So since we know the total outcomes, if you add all these probability, green, green, from here, green, 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 red, you add all these, the sum here should give 1. The sum of the probability should be 1. All of them. Then if you subtract the probability that the marble picked was green in color, you shall remain with the probability that the marble picked was red in color. So this will give you 1 subtract the probability that the marble is green in color, or the ones that I've ticked here. If you subtract all those, and that is what you've got, is 20 over 49. What is left is the probability that the marble picked was red in color. So that is how easy it is. Since we know that the sum of the probability of all these outcomes is 1. So 1 subtract 20 over 49, this will give 29 over 49. And that is how you're supposed to work out that question.